Section 8.1, Sequences and Series. Students will be able to find the sum of series and use summation notation or sigma notation to write sums. So first off, what is a sequence and what is a series? A sequence is a function whose domain is the set of positive integers. So we're only looking at this set of positive integers when we're looking at a sequence. The function values a sub 1, a sub 2, a sub 3, and so on are the terms of the sequence. So just some pretty generic examples, 1, 3, 5, 7. 9, and then we also have 1, 1, 2, 3, 5, 8, 13, 21, and that is a famous sequence. It's the Fibonacci sequence. So those are sequences. A series is the sum resulting from adding the terms of a sequence. So the series actually uses the sequence and then adds all those numbers up. So for example, 1 plus 3 plus 5 plus 7 plus 9 plus 11 is 36, and so on. Either way, sequences and series can be finite or they can be infinite. So they can either stop, like this sequence only has 3 or 5 terms, but the Fibonacci sequence, ... continues to go on. So it's an infinite sequence. So we're going to be using the summation notation or the sigma notation to show a series. So a couple things here as you write this. So this E-looking thing, that's your sigma. And what you have is n is the variable. So when you have this value right here, n represents whatever variable it is that you're using. That's why you see the f of n also there. So n is the variable. This is called the index of the summation. A is the starting value of n, which means it's the lower limit of the summation. So you have your A, so n equals 0, n equals 1, whatever that lower limit of the summation is. And then B is where you're going to end that final value, or the upper limit of the summation. And then f of n represents the function that you're using to find the nth term of the sequence. Okay, so this is read if you've never done summation notation or sigma notation for series before. This is read the sum of f of n from n equals a to b for a finite series, or if it's an infinite series, then the b value will be infinity, so it'll be as n equals a to infinity for an infinite series. So we're basically going to look at two different examples here. The first example is just to find the sum. So I'm going to give you one to look at, or I'll do a couple with you and then kind of pause and have you do a couple. So the first one, A, you can see that n is going to be equal to 0, so that's the lower limit of the summation, and then the upper limit of the summation is 7. The function that we're looking at is just at n equals, or the function is just n. So all we're doing is plugging in n equals 0, and if we plug in n equals 0, we just get 0. And then we go to the next one. So when n is 1, you plug it in and you just get 1. And then when n is 2, it's 2. And when n is 3, it's 3, and so on. But you only go until you get to n equals 7. And then you stop. And then you add all these numbers up, which are a total of 8 numbers here. And you add all those numbers up and you get 28. So that's how being able to find the sum works. Let's take a look at another one that's a little bit more complex. So on this one we have k equals 3. That's your lower limit, and it goes to k equals 8. The function is 2k minus 5. So I'll write this one out to help you see everything. So when k is 3, that means you're going to have 2 times 3 minus 5. So that's your first term, plus. And then you'll do it again when k is 4. And then again when k is 5. So it would be 2 times 5 minus 5 plus 2 times 6 minus 5 plus 2 times 7 minus 5 plus 2 times 8 minus 5. And then you calculate all these values, and so the first one would be 1 plus 3 plus 5 plus 7 plus 9 plus 11. And then if you add all those up, you will get a value of 36. So the summation For example, B would be 36. So go ahead and pause the video and try to do C and D on your own, and then we'll check them. Alright, so hopefully you had a chance to look at examples C and D. C, J is going to start at 0, so if you have 4 to the 0, 4 to the first, 4 to the second, and 4 to the third, you only go up to that upper limit there. And so once you do that, you get 1 plus 4 plus 16 plus 64, which is equal to 85. On D, it's a little different because we're going to infinity. So we know we can't just keep adding the numbers over and over again. At some point we gotta look at the whole thing and see what's happening. So when you plug in 0, you get 1. You plug in 1, you get a half. You plug in 2, you get 1/4. 3, you get 1/8. 4, you get 1/16. So as you're adding, you have 1 plus 1.5, 1 plus a half would be 1.5, plus a fourth, and so you're continuing to add a smaller fraction each time. But what is happening? As you continue to add, the fractions get smaller and smaller and smaller. So you could try this in your calculator and plug in 5, 6, 7, 8 terms and see if you could see what is approaching. And if you do that enough, you will recognize that this is getting closer and closer and closer to the value of 2. And so when we go to infinity, if you think about what I just said, is it's getting closer and closer and closer. So that's why we're doing sequences and series, is because when the series is going to infinity, you can see in terms of as it approaches that, what is the limit as it continues to go. So for this one, it would get closer and closer to 2, so we would say that the sum would equal 2. Alright, and the last thing I'm going to ask you to do is to work backwards, which is probably the little bit more challenging part of this. Write the following in sigma notation. So I'm going to give you a sequence, or a series actually, because you're going to be adding them up, and you need to figure out how you're going to write the sigma notation for that. I'll give you some kind of tips as we go along here to help you in terms of writing these. So example 2, we have 3 plus 6 plus 9 plus 12 plus 15. So if you look at the pattern, each time we're just adding 3 over and over. This is an arithmetic sequence. 3, 6, 9, 12, 15 is arithmetic sequence. So you're adding 3. If you add 3 over and over and over again, what is adding repeated addition? Well, repeated addition is multiplication. So when you go to figure out what this function is, what I want you to do is think about that repeated addition. We're going to represent using multiplication. So it's 3 times n. Okay? And since the sequence or in the series starts at 3, we're going to do 3n plus that first term of 3. If we do that, where does n start? Well, if n is equal to 0, 3 times 0 would be 0. 0 plus 3 is 3. And then if n is 1, every time it's going to be 3 plus 3 is 6. But then when n is 2, now it's 3 times 2. So every time it creates another addition of 3. And so how many times are we going to do this? Well, if n is 0 here, then it's 1, 2, 3, 4. So this would be, your upper limit there would be at 4. So that's an arithmetic sequence where you're adding a number over and over. On part B, when you look at this series, the sequence of the numbers is multiplication. So what is repeated multiplication? Well, repeated multiplication is exponents. So this one is being multiplied by 3 every time, so our function would be 3 raised to the n power, but you're starting at, once again, your first term is 3. So we have 3 raised to the n times 3, or if you want to write it as 3 times 3 raised to the n, either way. What do we start n at? Well, once again, we'll start n at 0, because this would be 3 times 3 to the 0, which is equal to 3 times 1. And then it'll have 3 times 3, which is 9, and then 3 times 3 to the second, which is 27, and so on. So once again, if this is n equals 0, we have 1, 2, 3, and 4 again. So A is arithmetic sequence, B is a geometric sequence. So I want you to pause the video and see if you can attempt to do C, D, and E on your own, and see if you can create the summation for these using sigma notation. Alright, hopefully you took some time to attempt to do some of these on your own. That's the way you're going to get better with this. But if you look at C, that's 1 over 1. So your numerator stays 1, so that's good. But how do you get from 1 to 4 to 9 to 16? Hopefully you recognize that as your numbers being squared. So the denominator would be 1 squared, 2 squared, 3 squared, 4 squared, up to 10 squared. So how would I write that? Well, 1, because that doesn't change, and then every number is being squared. So we'll just say n, and then square it. So what do we start n at? Well, if we want the first one to be 1 squared, we want to start at n equals 1, and that will go all the way up to n equals 10. So that would be C. And there are multiple ways to do this. So if you have something else written down, let me check it. But as long as it satisfies what the series is, it'll work. It has to satisfy the whole thing though. So on D, we have, once again, repeated addition, or repeated subtraction, but you're adding -5 over and over again. So that would be -5n, and then you're starting at 24. So this is an arithmetic sequence. So -5n plus 24. So when n is equal to 0, you'll get 24. When n is equal to 1, now things will start going down by -5. That's that repeated addition. And so if n is equal to 0, we got 1, 2, 3, 4, 5. So your upper limit would be at 5. And then on E, we got repeated addition again. So plus 3, and plus 3, but it does go on forever. So this is similar to 2a, except now we're starting at 10. So we're still going to have the 3n, because it's repeated addition, plus 10, and if n is equal to 0, it'll start at 10, and then you'll go up from there. And since it has the 3 dots at the end there, that means it goes on forever. So that's a finite series that we're looking at. So that is it for sequences and series. On the summary, though, I did write down the generic form. If you are having trouble using the geometric and arithmetic sequences, if it's repeated multiplication, it's a geometric sequence, and your formula that you would use is a sub 1, which is your first term, and then r, which is your common ratio, raised to the k value, which starts at 0, and then n minus 1, that's how many terms, so it'll always be 1 less because you're starting at k equals 0. For the arithmetic sequence, you still have the a sub 1, but arithmetic is repeated addition, so it's a sub 1 plus, and then k, once again, that represents 0 for the first part, and then d is the common difference, and once again it'll go to n minus 1 as your upper limit. So those are the formulas for geometric sequence and arithmetic sequence by creating those. So if that helps you work backwards on these, then definitely do it.